Hi everyone, Dusty here from Discovery Lab in Tulsa, Oklahoma for Discover at Home, a series of experiments and activities that you guys can perform with a parent or caregiver at your own home. Our activity for today is our spinning top creatures, where we'll be learning about electrons and electricity. We've partnered with the Opportunity Project to create these take-home kits. Let's talk about what's inside of them. The first thing you'll find is a length of copper wire. You'll also find some sandpaper, a battery, 2 small magnets, tape, construction paper, and scissors. You'll also have our instruction kit that we'll send with you inside of our bags. If you don't have the Opportunity Project kit, you can find these objects laying around at home or get them wherever you want. Before we begin our experiment, we need to talk a little bit about electricity. How many of you guys know a little bit about electricity? I bet a lot of you guys know that it's a form of energy or power that we use every day. It turns on our lights, our devices, it even helps us start our car. But do you guys know what makes electricity? You guys probably thought that hydroelectric dams, windmills, coal power plants, or even nuclear power plants create electricity. You wouldn't be wrong, but how do they make electricity move? Well, to answer that, we have to get even deeper. It's all because of atoms. Have you heard that word before? An atom is the smallest piece of matter. For instance, the smallest piece of oxygen I could get would be a single atom of oxygen. Similarly, the smallest piece of carbon, silver, gold, or copper I could get would be a single atom. Depending upon which element it is, each atom is different. However, all atoms have 3 things in common. They're made up of protons, neutrons, and electrons. Which one of those do you think is most important for electricity? That's right, electrons. Protons and neutrons are in the middle or nucleus of an atom. Electrons are found in a cloud around the atom. Envision it kind of like a beehive, if you will. The protons and the neutrons are in the middle of the hive, whereas electrons are the bees that buzz all around the hive. They're always moving and floating around the hive. They've got a lot of motion and energy. Similarly, how those bees could fly off somewhere, electrons can actually leave their atom and go to a different atom. Whenever these electrons move from atom to atom, that flow is called electricity. So, whenever you turn on your lights, you're actually making electrons flow. Certain objects are better at letting these electrons flow than others. For instance, remember how I said gold, silver, and copper? Those are 3 metals. They are very good conductors of electricity. They let it flow very easily. However, certain things stop electricity from going through. Things like plastic, glass, and rubber. They insulate. They keep electricity from flowing, which is good because we might not want electricity to get into places. It can short circuit and be dangerous, causing fires, hurting us, or even causing damage to our buildings. That's why we need to know exactly which substances let electricity flow, conductors, and which ones resist or insulate against electricity. Whenever electricity flows, it creates what we call a current. A current is a closed loop or circle of electricity that does work. Whenever you plug your batteries into your remote control, you might notice that there's a metal prong at each end. Electricity has to go all the way up around one side and return, creating a circuit. What shape can you think of that has a sound that sounds like circuit? Did you think of circle? You're right. Whenever we use that word circ, It means to go around, just like a circle goes around. So a circuit of electricity is electrons moving in a circular path all the way back to the beginning from where they started. Now, a lot of really interesting things happen whenever electricity flows. Believe it or not, flowing electricity can actually create a magnetic field. That's right, electricity can make things magnetic. That's an example of an electromagnet. I've got a real simple one I'm going to show you. I've got a nail and I have wrapped copper wire all around it. This nail is made out of steel. It's an alloy of carbon and iron, which is a metal. It conducts electricity pretty well. So does copper. That means that electrons are going to be able to flow through this guy super easily. However, something funny happens. Electrons have a charge. They're negatively charged. So that means that they can actually push or attract different parts of other atoms, depending upon their charge, kind of like magnets. As these electrons go around and around and around, they can push all of one charge to one side and all the other charge to the other side. That can take this steel nail and turn it into a magnet. I've got some paper clips right here, and if I just touch, you can see they're not attracted. However, whenever I take a battery and I touch both ends of the battery to my copper wire and create a circuit, I'm creating a flow of electricity. Now, let's see what happens if I touch this to my paper clips now. You can see they're magnetized. They get pulled to it. The flow of electrons has created a magnetic field that lets me hold these guys. Let's see what happens when I open or break my circuit. As soon as electricity stops flowing, the magnetism stops and it drops them. So you guys can see how electricity and magnetism are related. Now that we've discussed atoms, electrons, electricity, and magnetism, let's begin with our project. First, grab your copper wire. You're going to bend it in half. Try and get it as even as you can so that both ends are the same length, and pinch it down tightly. Should end up with something a bit like this. Now, because copper is very, very, very good at conducting electricity, sometimes we put what's called a coating over the top of it so that electricity only goes to places that we want it to. This is usually some type of paint or plastic. We want to scrape that plastic off. That's where our sandpaper comes in. Grab your sandpaper and sand the top of this bend in your copper wire. Just a little bit to rough it up and really get that plastic off. Next, you're going to fold it out like so. So you should have a shape just like this. Now, pull up the ends one more time, and you end up with something that looks a bit like a W. Go ahead and set that to the side for now. Grab your magnets and your battery. Take the magnets and set them on one end of your battery. They should be attached to it because this is metal. And because this metal is magnetic, the magnets are going to attach to it. All right, grab your copper again. Remember that coating I talked to you about? We need to take it off the tips as well. So this end and this end, we need to sand. Don't worry about it being perfect. Just try and scrape it a few times to really scuff it up so that way our electrons can flow very easily. Okay, now for this next part, you're going to have to make a few slight adjustments. You can curve it out, you can bend it in, but what you want to do is you want to make it so that way whenever you set your copper on top of your battery, the two little tail ends touch the batteries. right there where the magnet is. So, mine looks a bit like this. Like I said, I'm probably going to have to make a few adjustments. That's okay. Set it down so that this middle part that we first scraped is right on top of your battery. Now, I can see that it doesn't quite touch, but even though you can still see that it starts moving, you might have to bend yours down a little bit so that way it makes contact. That's okay. It only has to make a little bit of contact. Whoa, mine went a little crazy. So why does it move this way? Well, do you remember what I said about moving electrons creating magnetism? That's what's happening here. Whenever these have electricity flowing through them, they have a magnetic charge, which makes them want to push against this magnet at the bottom. That's why it wants to dance and spin around. Let's look at it again. Now remember, this part right here needs to touch the top of your battery, and then these two little legs need to be able to touch the magnets at the bottom of your battery. Let's get it on one more time. Oh, I bent mine a little bit too much out of shape. It just has to barely touch it, and let's see. Yeah, there we go. And you can see it starts dancing and spinning around. This is called a homopolar motor that we've created. Pretty fun, right? Let's make it even cooler. We also gave you some tape, some paper, and some scissors. This is so you can create a fun dancing, spinning creature. If you want to get some markers, some pencils, any other type of art supply, that's cool. But we're going to make something that we're going to tape to our creature so we can watch it dance or spin around. I think I'm going to cut out some wings for my guy. You could give them a tongue, a tail. You could make them look all kinds of silly. You could try and make them look as pretty as you want, as cool as you want. It's up to you. It's your creation. I'm actually going to trace over this one, I think, so that way then I get both the same size and shape. So it looks really good. Now, if I had a pencil, I could add detail to this. Ooh, if I had some googly eyes, I could give it eyes. That'd be really cool. The fun part about customizing this is making it your own. All right, I've made some wings for my creature. I think they look a little bit maybe like butterfly wings. Now I'm going to tape them down to each side. We've given you some really cool tape so you can really make it unique and make it your own. There's one piece. I'm going to tape it down. Now, whenever you're taping it down, make sure you remember that it needs to spin. Tape it in such a way that it's not going to block it from spinning, or that it's not going to block the electricity from flowing. Remember, the only places that electricity is actually flowing are those places that we sanded. So tape it over places that we didn't sand to ensure the electricity can still flow. There's one wing, and let's get one more. All right, tape that guy down. Well, I intend them to be wings, but they're looking a bit more like elephant ears. That's okay though. I think it's going to look really cool when I make it spin. In the sheet we gave you a little bit of a stage for your character to dance on. If you wanted to, you could make an even cooler place, making it out of recyclables or whatever you have at home. All right, let's see how this guy dances. So set him down on top. Make certain that I just barely touch those magnets. At the bottom, let's see. Oh, I can see I've made my wings too tall. They're brushing against the bottom and they're having too much rubbing. So I'm going to have to trim them off a little bit to make them a little bit shorter. That's okay. That's half the fun of science, is getting to know what's messing up and knowing how to fix it. All right, there we go. That should be better. And then make one more adjustment. I got them a little bit bent. And set them down. And let's see. There we go. Turning around a little bit. Like I said, you're going to have to make adjustments every once in a while. Oh, there we go. Now he's dancing. He's spinning kind of funkily. I might want to make a few adjustments to make certain that the copper is still touching the battery. It looks like it's only touching on one side. I really need to touch it on both sides to make certain that I am creating that good circuit. So let's try and bend these just a little bit more to get them touching. And you guys can see I'm having to keep working on this. So don't worry if you don't get it the very first time. That's just part of learning about how this works. Let's see, bring it in just a touch more. Ooh, too tight. Oh, there we go. Now he's dancing. Oh, there we go. Spinning around. All right, well, how did you guys turn out? Did you have as much trouble as I did? That's okay. Like I said, a lot of these experiments are just about the fun of learning it. Don't worry if you don't get it perfect the first time. I didn't either. What are the hardest problems that you guys had while building this? Did you have the same problems as me, or did you have different ones? I want to hear all about it on our Zoom call later. What are some questions that you have for me? How would you take this project and make it bigger and cooler? I'm super excited to hear what you guys have to say. That's going to do it for our spinning top creatures. Hopefully you guys had a lot of fun learning about electricity and magnetism with us. Thanks so much for hanging out, and we'll see you guys next time.